Hey everybody, welcome to week 1 of Marking Period 4's virtual learning. It's me, Miss A, and I'm glad that you guys are here to view all my viral videos. This week is going to have a goal of using our rules of exponents and rules of radicals, which we've previously learned before, and we're also going to do something new and become comfortable with going back and forth between exponential form and radical form. This video has been chunked into 3 parts for those of you who are looking to either chunk your learning or chunk your practice and your assignments. After each part, I will pause so that you can easily pause this video, and I will also tell you the corresponding Delta Math assignment that goes with this practice if you are using the Delta Math platform like my students are. So here goes part 1. Part 1 is all about reviewing the rules of exponents, but this time it's going to be with fractions. You can find this chart inside of your textbook. I also happen to add at the bottom here a reminder of your rules of radicals because we are going to be using these again as well. Just things are going to be a little different this time. Now we're going to be dealing with fraction exponents, and we're going to be dealing with radicals that are not just square roots, but third roots, fourth roots, fifth roots, and so on. I strongly suggest putting this into your vocabulary notebook. All right, rules of exponents, but this time with fractions. I've done some of the work ahead of time so that you guys can cut down on the length of this video. When you're multiplying your like bases, you're going to add your exponents, which means you need a common denominator. So as you can see here for my first example, when I'm multiplying these like bases, I'm going to add these exponents. They both need a common denominator of 6. When I add 4 6 and 3 6, I get 7 6, which becomes my final answer for my exponent of my base of x. Over here in my second example, I've got x to the third times x to the 4 thirds. If you notice, this one is not written as a fraction. I always like to write everything over 1 so that my eyes are not playing a trick on me. My common denominator is 3, and when I add them, 9 thirds plus 4 thirds is going to give me 13 thirds as my final answer for my exponent of x. If you're dividing like bases, that means that you're going to subtract your exponents and you're going to need a common denominator. You should always write your answer in the numerator, even if the answer gives you a negative exponent. I know for my students, I've always used the trick who has more and how many. Right now, this really isn't the best time and place to be using this. It's a common mistake to assume that one fraction might be larger than another and accidentally get an incorrect answer. So always put your answer in the numerator, even if it's negative, and you can always just take care of it later. So for my first example, we're going to divide these like bases, which means we're going to subtract our exponents. So it's always the numerator's exponent minus the denominator's exponent. Again, I needed to find a common denominator, which happened to be 6. So 3 6 minus 2 6 leaves me with 1 6, and that is going to be the exponent of my base of x for my final answer. Over here in my second example, you'll see that I have a whole number exponent up here. So again, I always like to put this over 1 so my eyes don't play a trick on me. So I'm going to have 2 over 1 minus 1 over 2. My common denominator is going to be 2, which is going to lead me to 4 halves minus 1 half, which is 3 halves, which is the final answer for my exponent of x. Remember, guys, if I'm going too fast, please feel free to pause and rewind. Negative exponents. Negative exponents are a way of telling you that a base is unhappy and needs to be moved. For instance, in my first example, x to the negative 3/4 is letting you know that it is in the numerator of this fraction, because remember, everything can always be put over 1, and it really wants to be in the denominator. Once it is moved, it is happy. My second example, this base has a negative exponent in the denominator, which means he really doesn't want to be in the denominator. He wants to be in the numerator, and once he is moved, he is happy. Remember, you don't always have to write over 1. In my third example, this is a common mistake. This base of negative 2 is fine where he is. He's happy in the numerator because remember, his exponent is 1. The exponent of negative 1/3 only belongs to this base of x, which is why x to the 1/3 was the only base that I moved to the denominator. Power to a power means you multiply, and in this situation, you do not need common denominators to multiply fractions. So again, I like to put whole numbers over 1 so that it's a fraction times another fraction, so my eyes are not playing a trick on me. You can multiply straight across, you can cross simplify, whatever is easiest for you guys. Just make sure by the end we all simplify and we all end up with the same answer. In this case, we are going to get x to the 1/3. My example number 2, we're going to have 4/3 times 2/3. And if we go straight across the top and straight across the bottom, we're going to get 8/9, and that fraction cannot be reduced. So our final answer is going to be x to the 8/9. My students are using Delta Math as their platform for their practice. So if you are as well, just so you know, these types of problems in Delta Math are going to show you some sort of problem on the left-hand side of the equal sign. On the right-hand side, it's going to say x to the a. What they are asking you to do is place this new exponent, so in these problems above, this would be our next exponent, in the answer box. A stands for answer, and all they're looking for here is the new exponent. This concludes part 1 of our video. So if you are chunking your work and your assignments for this week, I suggest that you stop here. Your Delta Math assignment is going to be titled Exponential Rules with Fractions, Level 1. Part 2. All right, guys, what's what? On the left-hand side, we have a radical form, and on the right-hand side, we have exponential form. These two forms you need to be able to convert back and forth between very easily in order to solve more complex problems. On the left-hand side, this small number here that is written next to the radical symbol is going to be called your index, or sometimes it's going to be called your root. When you convert this to exponential form, it will become the denominator of your exponent. And the silly way that I use to remember this is roots grow on trees on the bottom of the trees, and so roots are in the bottom of your fraction. The number or the variable that goes underneath your radical symbol is called your radicand. This is going to turn into your base for exponential form, and also is considered a base when it has an exponent here. Remember, exponents don't always have to be written if they're a 1, but regardless, exponents are always written here and sometimes referred to as a power. Exponents are always written up high, and when we rewrite this in exponential form, again, they say in the numerator, they're up high and sometimes called your power. So your power goes in the numerator, your root goes in the denominator, and your base is your radicand. Make sure you can go back and forth between these two forms. Okay, so here are some examples. Whatever form the original problem is written in, you are going to transform it into the opposite form. Here we're starting out in exponential form. Let's write it in radical form. Remember, your numerator is your power, and your denominator is your root. Remember, roots grow on trees on the bottom. So they're in the bottom of our fraction. So if we rewrite this, we would have the 4th root of x to the 5th power. Or I'm going to constantly remind you guys that you can write it as the 4th root of x all raised to the 5th power, because this form is sometimes helpful when we're solving more complex problems later. But either answer is acceptable. Let's try one more. Remember, this is your power and this is your root. So it's going to be the square root of x to the 3rd power, or the square root of x all raised to the 3rd power. Notice that I did not write the index of 2, because remember, in math, if we leave something out, it is assumed. Our smallest root that we can have is 2, square root, because there is nothing smaller than a square root. Reason being is because, remember, when you break down radicals, it all has to do with multiplication, and you need at least 2 values to multiply. Example number 3. Now we're going to go from radical form to exponential form. So remember, this number here is your root. It goes in the denominator. This number here is your power or your exponent. It goes in the numerator. So this is going to be rewritten as x to the 3/5 power. Example number 4, remember, if you don't have an exponent, it is assumed to be 1. So this would be rewritten as x to the 1/3 power. And example number 5, remember, if you don't have an index, it is assumed to be a 2. So this is rewritten as x to the 7/2 power. This concludes part 2. So if you are looking to chunk your work or your assignments this week, I suggest you pause the video here and you go and practice Delta Math, exponential, and radical form. Part 3. All right, so this is the good stuff. This is where you actually get to simplify more complex expressions, but you have to know all of your rules because now you need to combine them all into one problem. So for example, problem number 1, I'm dividing like bases, which means I need to subtract my exponents. 8 minus 3 is going to leave me with n to the 5th inside of the parentheses. This is still being raised to the 4/5 15th power. Now I have power to a power, which means I multiply. Again, I would put this over 1 so that your eyes are not playing a trick on you. 5 over 1 times 4 over 15 is the math that you're going to have to do. For those of you who are experts when it comes to fractions, because you are fraction lovers like myself, you can cross simplify if that's something that you feel comfortable with. If not, use a calculator maybe to help you to simplify. We should all get the same answer of 4/3 at the end. So our final answer is n to the 4/3. Again, if you are like my students, then using Delta Math, some of these questions are multiple choice, and they don't write the final answer in the same form as the original question. Sometimes they write it in the opposite form. So an answer that you might be looking for is the cube root of n to the 4th power. Both of these answers are correct. They're just written in different forms. Example number 2, I'm multiplying like bases, so I'm going to add my exponents. -6 and 5 are going to give me -1. Don't worry about the fact that this is negative right now because we're not providing a final answer yet. Now I have power to a power, so I'm going to multiply, which is going to give me n to the -1/4. Now this is not an acceptable final answer because remember, negative exponents are a way of telling you that this base is unhappy where he is. So remember, everything can be put over 1 to be turned into a fraction. So we should change this into 1 over n to the 1/4. Or again, if you are working in Delta Math like my students, you might be looking for an answer choice that looks like 1 over the 4th root of n. Last 2 examples. Starting off in radical form, underneath the radical, we're going to be dividing like bases, so we're going to subtract our exponents. If you don't feel comfortable subtracting a negative, I would bring him up top so that he's happy, and then you could add your exponents because you're multiplying like bases, but either way, we should all get to the same answer of having x to the 4th underneath the 16th root. Now, some of you may think that you're done, but remember, if you were to change the form, these 2 numbers come together to make a fraction. You need to make sure that that fraction is in its simplest form in order to say that you have simplified your answer completely. So let's change forms. It turns out that our fraction of 4/16 is not in its simplest form. 4 goes into both of those numbers, so if we simplify, we get x to the 1/4, or again, sometimes you might be looking for the 4th root of x if you're working in Delta Math. And number 4, underneath the radical, we have a to the 1st. Remember, if you don't have an exponent, it's always 1, times a to the 8th. So we're going to add our exponents, and we're going to get the 24th root of a to the 9th. Again, you might not be done here because these 2 numbers come together and make a fraction exponent, and we need to make sure that it's in its simplest form. So if we rewrite this in exponential form, it's going to be a to the 9 over 24. 9 over 24 can be reduced because 3 goes into both of these numbers. So we're going to end up getting a to the 3/8. Again, if you're working in Delta Maths, you might be looking for the 8th root of a to the 3rd. This concludes part 3 of our video. Again, if you were chunking your work this week or you're learning, I suggest that you go on Delta Math and work on exponential rules with fractions level 2. Since these are more complex problems, I do suggest doing the work over the course of 2 days if you would like to chunk your work even further. Thanks, guys. See you next week.